there we will have information about our meetings this year. We're in the process of scheduling February, which will be, I think, an interesting one about building our packages using Rust code. So that will be great. So you can look for that there, get those announcements there. And then I think a little later in the spring, we'll do another in-person Salt Lake City networking event when the weather warms up just a smidge. So that will be fun. We are supported by the R Consortium, and we use the R Consortium's code of conduct. So I just dropped that in here. So this is a friendly and professional space, and Andrew Red and I are the organizers and are the people who are moderating, and we use this code of conduct where we treat each other professionally as we would if we were in person in a room together. So you can check that out. Today is and we're doing lightning talks. We've done this in January for a number of years, which is pretty fun to be able to get just like a real fast little sharing of information from somebody on a variety of talking points and topics and all that. I know from experience that giving lightning talks can be pretty challenging. So I really appreciate the folks who are willing to put these talks together and come and give us a little bit of insight into the kind of thing that they have been working on lately. We have got 5 lightning talks here today, and so we have asked everybody to present for 5 to 7 minutes. Since we've got 5, we do have a little bit of time for questions. So as somebody is wrapping up, if you've got a question, you can type it into the chat, and we can like take some time to do that. Or if you want to use the Zoom hand raising feature, we can do that as well and do catch maybe a question or two for these different folks as they come through. So use either type in the chat or go ahead and use the hand raising feature, and we can unmute you and you can ask a question if you've got that. I think that's it. Andrew, is that all our announcements for today?
We have one more thing on the Zoom is I'm trying the AI companion. So if you need to ask questions there to summarize what we've done, we've never used it before. I've never turned it on before. You're welcome to use it if you want to.
Great, great. Thanks, Andrew. Yeah, we can try that out. Awesome. All right. So let us jump into our lightning talk. So our first lightning talk is from Willie Ray. And Willie, if you want to get your screen share set up. Willie, I'm excited for you to give this talk because it's something that I have dabbled in a little bit, but learning how to use branding.yaml, how to do some branding here. Thank you for sharing your screen. Kick us off here in this lightning talk session by telling us about brand.yaml.
Okay, so the grant is from the Centers for Disease Control, CFA, Center for Forecasting and Outbreak Analysis, and it was sort of this umbrella grant that said we need to give the research enterprises the ability to push expertise into the local public health, the public health services. And so we were talking to them and what their problems were, DHHS and some of the other folks. And what came up was there's all of this friction at the beginning of a Shiny application or at the beginning of a QMD report about getting it set up and starting and having it look the same every time and all this stuff. And so we looked around and we decided that what we ought to do was build an R package that would manage those startup costs a little bit and try to facilitate and streamline the beginning of the thing. So what we landed on was our branding. This is our branding package. You find it on GitHub, and you can also install it from CRAN or from our universe. And what it's going to do is give you a starting point for Shiny application or a website or a report that is automatically ADA compliant off the top, and then that uses a standard brand.yaml. So brand.yaml is a standard from POSIT, I think. Is that right?
It is right, yes.
that is trying to be that's trying to single source the branding information for a given enterprise. So you have CSS files for your website, and you have a big PDF document that says what all the colors are for your print publications. You've got all this stuff. Brand.yaml is supposed to bring it all under one roof. I can show you what a brand.yaml file looks like. There's not much to it, but it captures all of the colors, all of the typography, all of the, it can have specific values for different output types, Quarto, Shiny, website. And then as we got working along with the thing, we realized there's a significant need for our sort of client agencies to be able to streamline with templates. And so at this point, we have a set of templates that are just starter applications. We've got a regular website one and some just our plot making ones, and several Shiny applications, and then just regular Markdown for reports and stuff. And the idea is probably just jump right into the workflow. Does that make sense? Let's say brand init. What this does is it creates a config file here in my project. All of these functions are configurable, so you don't have to have it dump right into the root of your project. You can have it go wherever else. I'm just using the default configs. So this is the source where it's supposed to be the canonical R branding YAML file, the canonical brand.yaml file for a given enterprise. And what I do in my project, I'm going to say get brand public. It does work with private GitHub repos. Thanks to Andrew Pulsifer for that code, actually. And look what it tells me, that my local file is diverged from the file that's specified in the config, and so it wants me to overwrite it. I'm going to go ahead and do that. And now I have the brand.yaml file from this GitHub repo plugged in at the very beginning of my project, and I can look at it and I can say, okay, what are the keys that are in this file, and how do I need to conform? And then I can look through the templates that we list, and I can say, I need this. Maybe this is the closest to what I'm trying to start, right? And so I look here and I say, oh, look, get template Shiny _ complex, and then that's how I run it. I'm just going to copy these to the clipboard. Just going to paste them in here. And so what's happened is now it's copied the entire template file. Oh, that's fun. Look at that. That's not what I wanted. That's what I get for hacking right up until the moment of the thing, right? Of course, that's what I always say. So here I have a starter Shiny app with an error on it, that if I've got a team, or if I'm just trying to get started on something new, I can say, hey, use this template, get it started. It'll share all one brand.yaml file, and that makes it so that all of our fonts are the same, all of our colors are the same. All of that stuff that has historically been so much friction for them at the beginning of a project is now, I know, Andrew, that seriously. Let's see, I bet I got another one I can use. One of the other features that we've got in here that's kind of cool is if I say get template, it'll tell me the templates that it sees that it can use. So I wonder if this will work. It copies those files in, and then I'm going to say this. Uh-huh. And so all the colors in this plot, and including that icon that's up in the upper right-hand corner, are things that are derived directly out of the brand.yaml file. So they're consistent and they can be applied across projects with somewhat more ease.
That's super cool, Willie. Whoops. And that's your 7 minutes. Perfect.
That's my 7.
Perfect.
Yeah.
Yes. Okay. So I'll just pause a moment if anyone wants to type a question here. Um when do you reach for the R package and when do you go straight to like passing around the YAML and whatnot?
Well, so this is kind of the problem that they've had at our local public health organizations. Like, uh, I've got the YAML, I've got the CSS files, but how do I know they're out of date? Someone has updated the style guide, but I still have the old files. There's no way to manage that. So
Right. Okay.
the thinking of the workflow here is that you would do this at the start,
Yes.
and then periodically you might get an email from some brand manager that says, I've updated the colors. And you would come in here and you would say, get template or get brand public. And it's going to tell you if you've got the latest version or
Okay, yes. No, I see. That's
right. Does that make
that's a
sense?
very clear like when you want this. Yes. Awesome.
Right.
Awesome. Thank you, Willie.
Yeah. Yeah.
We'll see
Thank
if
you.
anybody else types a question in here for you about using brand YAML in this way, which is great. And we'll have you stop sharing and we will move
Acknowledged.
over to our second talk, who is from Greg Snow. So Greg, thank you so much for prepping a talk to share with us. Tell us a little bit about our 6 counters and progress bars.
Okay. Um, so I want to talk a little bit about R6 progress bars. This is actually somewhat promoting a package that I'm working on called R6 Toys. So the progress bars are part of that. This is very pre-beta, probably even pre-alpha. I don't know what comes before alpha, but if you want to install the package to see what's there, not very much documentation yet, but you can check back from time to time. But you can install it from GitHub, GL Snow R6 Toys/package, and you'll get that. But just a quick partial history of progress bars in R. So those of us who have been using R long enough remember back when R did not have any progress bars, and various people started adding progress bar code to their various packages. I was one of the guilty parties and probably one of the last ones because when I published mine, an offline discussion ensued. I think I had a small bug somewhere that led to this. But Professor Brian Ripley, part of our core, referred to my progress bars as the ugliest he had ever seen. I should have kept that email to quote him in that. Mostly we got along in that, but that. But apparently, one of my claims to fame is that it was just ugly enough that it convinced Professor Ripley to, as a member of our core, that he added what we have now, the progress bars that are in R itself. Um, so I can't say that I put them there, but I inspired him to put them there with my ugly code. I still disagreed with him on some of the user interface, but because he's Brian Ripley and I'm not, and he's part of our core and I'm not, he won that discussion. But he did tell me, it's like, well, if you don't like how I do it, write a wrapper. And so that's what the R6 progress bar uh, object does, is it's a wrapper around the existing functions. So you get the same progress bars, the same functionality, and that, but what I think is a better interface. Now that's my opinion. Yours may differ, his differs in that, but it uses the R6 object-oriented programming to do that. Okay, so just as a comparison, so using the built-in ones, if I wanted a progress bars with the so running with the function replicate, so I first create. So this creates a Windows progress bar. If you're not on Windows, you need to do either TK or text there. But you create the progress bar, and then inside of my replicate, here's my code I need to run. I need to do something like get the current value of the progress bar, save that as temp, and then set the progress bar's value to temp plus 1. So that it will increment it, and then I do the rest of the code that I want. When I'm done using it, uh, you can close the progress bar, and then you still got this PB thing sitting around. And so if you remove it, though of course it can get deleted automatically if you don't save your things there. So my approach, you do need to, install and then load the package. So similarly to here, I create the progress bar using the R6. So it's R6 progress bar $new. But here's the nice thing is I don't have three different functions. I just have an option for which type. So if you don't specify the type, it actually defaults. It'll try to do win, then it'll try to do TK. If neither of those are going to work, then it will do a text one, but you can just specify it here. With the current one, if I want to switch to a TK progress bar, I have three places in my code that I have to change that. Whereas with the R6 one, I just change this type right here and it remembers everything else there. And then instead of these two rows here of finding out what the current value is and then adding one to that and setting it, I just take my progress bar, run the increment method or inc for increment method that updates the progress bar, and then I run the rest of my code. When I'm done with it, if I remove the progress bar, that does the closing on it as well as part of the finalization. Now the progress bar for Windows or TK1 doesn't actually disappear until that thing is garbage collected. So, the finalization there. So that's kind of my improvement. Um, if we use something like sapply, and I did test this, this also works with map from the per package. But here I'm assuming I already have a progress bar that I've been using before. I've got this myFun is the function that I want to use with sapply uh, or map or something similar. Now, if I'm doing a for loop from 1 to 1,000, I can just use set progress bar with that number. But these are the cases where I like my interface better. But the built-in, we'd reset our progress bar with set win progress bar. And then again, now we need to kind of write a wrapper function with sapply. So here's my anonymous function that updates my progress bar and then runs the function. Whereas with my R6 progress bars, I have this method called run, where I just pass in my function and it will basically wrap that in something similar to this and automatically do the incrementing there. So that's, I think, a lot more simple there as well. So that's a quick and dirty introduction to my progress bars. Again, if you want to play with these, install it from GitHub. And my conclusion is go forth and bar progress. I mean, show your progress.
Thank you, Greg. Thank you so much. And I think most people probably have heard of R6 methods and whatnot. Can you tell me, like a little bit about like when you reach for this, like when you decide, this is the thing that I want, and this is why I want to, for example, like build the infrastructure around it for like progress bars in this case.
So R6 is really great anytime you want to save state. So in this
Great.
case, the progress bar we're updating. So even with the built-in ones, you're saving the state, but it's kind of a mix of object-oriented and functional programming where you have to pass that PB object and then it gets updated. R6 is the more natural where it's internally it's still doing the same thing. It's got its own counter, but the interface is, well, I've got this object. When I run a method on it, it's going to update the right parts of the object, but then it just kind of encapsulates everything really nicely in a like a little bit more efficient. I understand. I believe Hadley Wickham did a bunch of time testing on comparing the R6 objects to the um, they used to call them S5, but they didn't like that. But the
Yeah.
Reference classes.
Yeah,
reference
yeah,
classes,
yeah.
that's right. And ended up switching a bunch of the ggplot2 code to using R6 instead because it was a lot quicker and a lot more efficient. And it's just kind of really nice. And so, I only have a few things in R6 toys right now, but if you keep a watch on, I'm going to add other things to kind of show you some of the the different fun things that are easy to do with the R6 packages, and a couple things that, if you want to pretend like you're working, but you really need a 5 minute, you
There
know,
you go.
there's some puzzles and games that you can do. It's like, no, I'm exploring this R6 package and how to use these R6 objects. I'm not really just playing with a maze here.
There you go. Awesome, Greg. Awesome. Thank you for walking through that. I do think it's really, I do think the, object-oriented programming in R it can be a little overwhelming, and so appreciate you walking through when you reach for it and why you go about doing that. Awesome. Thank you so much, Greg. All right, we're going to move on now to our third lightning talk from Andrew Pulsifer. Thank you so much. Looks great. So, Andrew, you're going to talk to us about Epitraxar. How do you say it? I forgot to ask you, Andrew. How do you say this?
Yeah, I say it Epitraxar, but it's probably
Epitraxar.
Epitraxar. You could do either.
Nice. Very nice.
Yeah.
Awesome.
Okay.
Tell us about it.
Okay, so Epitraxar is this package we built for local health departments, specifically epidemiologists, and it was kind of designed to be their best friend for reporting. So this was developed at the University of Utah, part of the same grant that funded Willie's thing, funded by the CDC, and then we partnered with Weber Morgan Health Department and Tri-County Health Departments, these kind of local county health departments in Utah, to help us develop it and get it right. But since then, other counties in the state have also adopted the tool. So it's proved itself very useful. The local EPI's best friend was actually what Tri-County Health called it. So kind of the slogan now. So just to kind of motivate why we did this, this is kind of the way disease data flows in Utah. Is essentially you've got your diseases, cases and stuff will be reported in homes or in hospitals. But all this ends up in EpiTrax, which is this central disease data repository that's actually developed by Utah's Department of Health and Human Services. And it's used in other states as well, but it's developed here and used here. So all of the disease data throughout the whole state goes here. And then your local health officials, your epidemiologists, your EPIs, will pull data for their jurisdictions on case counts and different diseases from this EpiTrax database. And the formatting of that data can be a little complicated and kind of hard to work with. But what they'll do is they'll then, without Epitraxer, they'll do a lot of this manually in Excel, but they'll build charts and make forecasts and write articles and things. And all of that data will go to policymakers to kind of improve disease management policy. Doctors will get reports on it, so they're aware of what diseases are prevalent in the community, and locals will as well. So this is sort of the way that this disease data runs. And but this process, for many of these local health officials, they're not super proficient R users. They're not necessarily, many of them may not have any coding experience whatsoever. So they're doing a lot of this manually and in Excel. And this can take 1 to 2 days each for a person working full time on this, like for 1 to 2 days of their work every month, because they'll do like a monthly report on diseases. So we wanted to automate this as much as we could with Epitraxer, and using R, basically turn those 1 to 2 days into like 2 seconds, right? But given this, there were some interesting constraints because we were writing an R package for basically non-R users, which introduced some interesting design problems. So with the package, the way it's structured is there's kind of 3 levels to it. The base level is sort of the core functions of the package. So these are, they might have different sorts of inputs. They take data, take different diseases that you want to include in your report. They might write a CSV. They'll have the output shapes are different. I find them useful, but I'm a lot more proficient in R. I'm more comfortable. So they're not very easily chained together. If you put these in a script, you're going to have a lot of supporting code to kind of link the inputs from function to function and build. They're often generating several reports in one go. They're doing annual reports and monthly reports and grouping the disease reports. And so their scripts get really complicated. So it requires more R experience than local health departments have, but we built it as kind of the first sort of core set of the package. But then to more effectively accommodate our users, we built these, what we call the pipe functions. And these essentially wrap some of those core functions. And then they behave kind of like a dplyr, sort of piping these things together, where they all take pretty much the same input, sometimes a few modifiers, but mostly they take this shared Epitrax object, and then they output that object so that you can just pipe them really cleanly together. It makes scripts, much cleaner, easy to read. Every line is a different report, or it's writing, CSVs or writing Excel files or something like that. And this makes it much cleaner for them, much easier. We still have to give them an R script. They have to load it, but essentially all the challenge for them is installing the package, making sure everything is set up correctly, and then they can just hit run with a new data file every time. Um, and yeah, and then obviously we can still use these, like more advanced users can still use these as well. But it just requires less R experience, this is the most popular for our local health departments who all have maybe just a little bit of R. They really like this, and it made it really easy to make it flexible for them. But then there are some of our local health departments with no R experience. So for those, we built an R Shiny app that kind of goes on top of, it's powered by these piped functions, but now they have a graphical interface. No R experience required. Go in, select your data export from EpiTracks, we have these two different disease lists, an internal disease list and a public disease list, because you might be generating different reports for different contexts. So you'd put all of those things in, generate all your reports in one go, and then download the outputs. And we found this to also be pretty popular, though I think most of our users end up using the piped functions. They find they have just enough R experience. They prefer the flexibility of that. So just the features. So this is all publicly available on CRAN. It's on GitHub. It's, we're still actively developing it and expanding it and making it more flexible for our partners. But here's some of the example of the type of reports they run. They do these monthly cross sections where they look at disease counts for a given month over the last 5 years. They'll do an annual reports, year-to-date reports. They want them in different output formats. Some want CSVs, some want Excels. PDFs are often for public-facing reports, ones that will end up on a website. And that also speeds up their workflow because they can get the report and they can slap it on their website right away. And we've saved them just so many hours with this package, and they've been really happy with it. And one other interesting thing I think that's interesting that we do with these public reports is for a public report, well, one, you might have a different set of diseases that you're reporting publicly. You might have some diseases that just the public don't care about or have so few cases that it's not really relevant to the public. But then the other thing is that you also need to do some conversions on the disease names. Because in the database, like chlamydia, for example, is chlamydia trachomatis infection. It's this kind of longer thing. And several of the diseases have these longer names in the database in EpiTracks, the formal name of the disease, if you will. But for the public, chlamydia is sufficient. Or there might be multiple versions of syphilis in the database, but for the public, they just want syphilis. So when we do a public report, there's kind of a conversion step where we convert the names to these public-facing names, and we also aggregate statistics for, so all those different syphilis get compressed into one syphilis statistic for the public. And that's been very useful as well. So that's the EpiTraxer package. You can find it on CRAN, find us on GitHub. It's open source, if you want to contribute to it. And yeah.
Awesome, Andrew. Thank you so much. I think if folks have questions, you can type them in or raise your hand. One question I have is, I'm all in on Tidyverse and the pipe, and like the packages I build often are very like pipe friendly because of this. What would you say drove that as the way to do it, even for something kind of this very complex, like building a whole report generation? Like, what about that sort of Unixy pipe type philosophy made it a fit for this kind of use case, do you think?
I think a mixture of things. Probably the main one would be usability. Like it's just so much more. We were giving these, we gave them an initial script using all those core functions, and the script was like 300 lines long. It was really hard to find things. It was complicated. It was very brittle. If you had some weird thing, the whole thing kind of fell apart. And so using the pipe, you get it down to like 20 lines, one per report. It's very easy to see, fix. Some of the reports you can have an additional selector input for public versus internal, and you can just, quickly make those adjustments. So that was, I think, probably the main driver of it. But then the other is it just makes it more robust in those scripts as well. Like it's easier to kind of have that core function running, but have this wrapper that's doing all this additional support work around it. And so I'd say that was probably the main thing. It's just more powerful, easier to use.
Yeah. Great. We've got one question here that's like about specifically to do with COVID. I'm assuming COVID is one of the things that are tracked here. If you imagine ourselves back to the time when like COVID first came and was like new disease, we have to start tracking. How flexible are this thing that you built in terms of like what kind of would have happened? Would you have had to do like a new release of the package to be tracking this new thing? Like what would have happened, or what would happen now if it was like new disease to track?
Yeah, so yeah, COVID numbers are included in those data sets. So the one of the main things we wanted to build this for was we wanted to make sure that any health department who uses EpiTracks, I mean, technically you could use it without EpiTracks as long as you were willing to make your data the shape of EpiTracks, do that step first. But you pull your EpiTracks data, it's going to have case counts on every disease in your jurisdiction based on your own filters, so that some departments might not be tracking COVID with this. COVID, because of the pandemic, has kind of skewed a ton of numbers. So sometimes they'll track that separately. But as long as it's in the data set, like the code doesn't really care. Like the package is agnostic to what the actual diseases in your file are. What we have our users provide is an additional disease list. It's like a CSV. It's just a list of all the diseases they want for internal reports and then a separate one for public. So if you were using this for COVID, yeah, you would just include COVID on that list. It gets included in the reports that are generated. One thing I will say though is one way this would have been helpful to have during COVID onset is that this takes 1 to 2 full days, and so as a result, they only do it monthly, and since finding out this can be faster, one of the main changes they wanted was actually additional weekly reports because now they can afford to run more frequent ones. I imagine that would have been very helpful at COVID, is that we could now run this, rather than taking all this effort. And so much effort was applied to COVID specifically that other diseases were kind of left behind. But
Yeah.
this speeds up so much of that process that would have been really helpful.
Great. Thank you, Andrew. Thank you very much. Awesome. All right, let's go to our fourth lightning talk here. Jashin is going to talk to us about finding polygons in snow load analysis. I'm pretty excited about this. Let's have you share your screen, and then we will kick you all your lightning talk off.
All right, can we see that okay?
Yes, looks great. Thank you.
All right, perfect. So thanks, Julia, and thanks to anybody else who helped organize this for having me. I'm going to be talking about some of my thesis research that's in conjunction with NASA as well as UC Boulder about interior roof polygon extraction for snow load analysis from the NSIDC LiDAR data. All right, so quick little lightning introduction about me. Grew up in Seattle, love to cook, read, watch movies, and travel. I spent some time in category management before pursuing my master's degree at USU. I'll graduate this semester and full steam ahead on finishing this thesis as well as finding a role for when I graduate. All right, let's jump into it. And, leaving a whole lot of the fluff and background of this out of the equation. So please, anybody who is interested in learning more, hit me up afterwards and we can talk about some of that stuff. But essentially, we're looking at some LiDAR data that was collected by the NSIDC in northern Fairbanks. So on the left, we have a picture of Fairbanks with a red circle that kind of identifies the area that we're looking at. And then on the right, this is just a Google Maps image of the area of focus here. We've got two little circles, one commercial, one residential. Those will be kind of our areas of interest or our demo spots as we move through this. Okay, here's what the sort of raw LiDAR raster looks like. It's stitched together a few different LiDAR swaths. You can see on the western side, that jagged edge is just the different swaths and where they don't line up, essentially. Big thing of note here is that in the margins, especially the north and the south, all of this white area is NA or missing data, and that's due to shadows because there aren't multiple passes of the LiDAR. And fortunately for us, that's where all of the buildings that we're interested in are. So we gotta deal with all of that missing data. Okay, here's what it looks like zoomed in on those residential and commercial areas that we identified earlier. And you can see that the missing data is just shadows on the southern side of those southern buildings from the LiDAR angle not being able to reach that point. These are all trees. There's in the bottom right of the residential area. And then the commercial buildings, they have a little bit larger shadows because they're larger buildings, taller buildings. Okay, so what we do, and actually let me move back here. So in order to get rid of the missing data, we're gonna slide a moving window over all of the NA spots, or those white spots. And we're just gonna look for at the surrounding pixels. We use KNN to split those up into roof pixels and ground pixels, and then we just impute the missing data with ground pixels, nearby ground pixels, or the median of those ground pixels. And so then we've got our cleaned up, nicer looking data. And now that we've got it cleaned up, what we're really interested in is defining some polygons for each of these buildings, specifically interior polygons, so that way we don't get any snow drifts that are right next to the building. We're looking at snow accumulation on building, so we want to create some interior polygons for each of the buildings. We were provided some polygons by the city of Fairbanks, and if you look closely, they're off-center. In most cases, they're either slightly shifted up or up and to the right, but they would include a bunch of snow drifts, and then also they miss part of the building, which isn't necessarily the big issue. The bigger issue is those snow drifts in the ground capture. And so what we are going to do is do another sort of sliding window for edge detection. And we do edge detection by grabbing the gradient magnitude at all of the points, and then just thresholding those gradients and keeping the top 30%. And so all of this yellow highlighted area is the top 30% of gradients. We get all of this tree noise again in the bottom right of the residential area. A lot of the residential buildings are connected. But mostly this doesn't pose too big of an issue. What we're going to do with these shapes that we've created is a couple morphological operations. We'll dilate them to make sure that they're all closed, and then do a thinning and grab the innermost ring. And then that leaves us with our interior polygons that are suitable for looking at snow accumulation on roof. And it works just as well in commercial as it does for residential. It's just that the residential buildings, the area that we shave off on the edge of the buildings is a larger percentage of the area because they're smaller buildings in general. We also get, like, there's a weird AC unit here that shows up on the bottom left commercial building. And then that other commercial building here, we get 3 separate polygons for its roofs. That's not really a big issue. We almost would want to treat them as separate buildings because of how different the structures are that connect that building. And then just scrolling back, if we take a look at this guy, which is an apartment building, we can look at the distribution of snow on roof. And our distribution of what we show is really high fidelity, matching the weather station report for the snow for the specific day that we have snow on LiDAR data. So that's just an example use case. More interestingly, we would like to start to look at how the snow is drifting and the drifting patterns. Here's some problem buildings that it doesn't work great for. On the right, we've got an elementary school that looks like the cross between like a Thunderdome and a shark's mouth or something. And we get multiple polygons inside the top of that building, especially like the roof anomalies cause sort of a big issue. It's not really a building that we'd want to look at as a standard use case for snow analysis anyway, but it is a good example of how our algorithm fails. And then on the left, we've got a pretty steep barn that goes almost all the way down to the ground. It just doesn't hit our gradient thresholding because it goes almost all the way down to the ground, so we lose a lot of that roof, and you can see it's a pretty jagged interior polygon that we end up creating. Now what we've been moving into is slope identification from these interior polygons. So this is what the Terra extract slope function looks like if we apply it to this roof on the left. And unfortunately, that function is flow-based. And so we get like a lot of variability in the slope on the roof. What we'd like to do ideally is look at the planar slope of the whole roof rather than the flow-based slope of the individual pixels, or the resolution here just causes a problem. And so what we've moved towards doing now instead is randomly sampling points on the roof, fitting a plane to those points, and then calculating the slope of that plane. And if we do enough samples of that, then we can end up with the dominant plane and then get a slope that's that reasonably matches what we believe the slope is based on surveys. Yeah, so all of the snow accumulation data that has been looked at so far, or most of historically, is survey based, and so being able to do this in sort of a large automated fashion has been really awesome. We're looking to roll most of these functions into a package as I finish up my thesis here. Shout out to Terra, SF, Tidyverse, TikTok, RGL, HTML widgets, our tools, and test that. And yeah, if you have any questions, feel free to hit me up later or ask now. Thank you so much.
Awesome. Thank you. That is really interesting. So I personally come from like an astronomy background and did a fair amount of like image analysis of like identifying things with like slightly different, a different set of scientific questions. But that was it was quite a long time ago and I did not know about R then. And what of all the kind of tools you feel like you could have picked up, would you say is it like the SF Terra ecosystem that motivates hey, this is good for this because of like the spatial statistics side? Is it like what would you say was some of the main reasons why like your group or you individually like decided to choose R here for this kind of analysis?
Yeah, great question. I think the largest benefit here is the ability for us, we sort of had a proof of concept, but if we were able to make these things work, get these interior polygons, and then maybe also do some feature extraction like the slope extraction, all of this is really well suited into rolling into a package and then uh, uh, folks being able to use going forward.
Yeah.
This initial analysis with the LiDAR data is motivating further LiDAR collection. And so, really it is would only be used on data that's well suited for these functions. So that
Yeah.
the scripting ability made R the best choice.
Nice. That's great. Thank you so much for sharing about your research and talking through that today during this lightning talk. We are now to our final lightning talk of the day from our very own organizer here, Andrew Red. Andrew, thank you for thinking through something to share today and getting this. We would love to hear from you to wrap us up.
Okay, great. I am talking about a project that is associated with Willie's project and Andrew Pulsifer's project. We started at a while ago and on this EpiTrax problem, and we're developing software and stuff for the local health department. And Willie got the branding package, and Andrew Pulsifer got um the EpiTrax-R package or EpiTraxer. And I was sitting, what am I going to do? And I said, we got this code that's been sitting around and it hasn't been packaged up, it hasn't been cleaned up. And so I'm like, oh, this will be a quick and dirty, quick and easy package up, put it out there, and be easy. And it was a very humbling experience because there were a lot of issues. And so I'm giving this lightning talk to present some of the issues that I came across of translating some legacy C++ code into an R package. So of course, this isn't my code. For what it was, it was well written. There were about 15,000 lines of code. The idea was to model infection transmission within a hospital ward or across multiple wards within a hospital. It was a standalone package. It worked really well for what it did. My goal was to package it up into an R package, so it could be distributed, used by researchers very easily, and make the user interface friendly. It was a bit more than I expect. I bit off a little bit more than I could chew at first. So the main issues that I want to talk about, three critical pitfalls. This isn't everything that I came across, but these are kind of three of the big ones that I had problems with. What first was memory management. It turned out to be a nightmare. C++ and R fighting over ownership of objects and deleting things when they shouldn't have been deleted and things like that. Static member deletion. The original code used static members that ended up getting deleted that caused what appeared to be random crashes. And then testing. Testing revealed a few bugs that were in the original code that were not caught in the original development. So digging into memory management and the nightmare that was. So the first issue was the double deletion bug. This what appears to be a random crashing. A segmentation fault is about one of the worst things that you can get when you're running an R program. It means that everything crashes. You don't get to recover anything. You're done. It's a no recovery kind of situation. You get the best you can hope for is a memory dump that you can then go in and figure out what was wrong. So here's the original code, is a function that said get facilities, and it returns a facilities pointer. The problem is who owns it? Does R own it? Does the original object own it? Who owns it? So you either end up R garbage collecting it, which means that the C++ code can no longer use it. Or if the C++ code thinks that R is going to delete it, you end up with a memory leak and your system gobbles up all your memory until it slows to a stop. So if you're passing it, then back to R garbage collects it, and then C thinks, oh, maybe I need to garbage collect it. It tries to delete it again, and the system says, no, you can't do that, and it crashes. So that was part of the problem. The idea being, the fix being that we included shared pointers. This required a change to the interface of the original code, something that was not something that I wanted to do at the outset, is to change the interface of the code. I just wanted to wrap it up and make it easy and just package it up, prettify it, make it pretty. Ended up having to change some interface API changes. The lesson learned, if you are dealing with C++ code, and especially legacy C++ code, never return raw pointers to internal members across the RC++ boundary. Don't ever do that. The orphaned allocation, same thing. If you are, who owns it? Does R track it? Does the system track it? This is the memory leak side of it, where if you're creating an object, you need to know who owns it. When you're crossing back and forth between R and C++, that can get very, very murky. The lesson being that every allocation needs an owner. Static member deletions. So the original code had a class with a static member that kept track of all the instances of this class. And then when you're cleaning up, you delete that code. But the problem is, in R, you're going to be calling it again and again and again. When you run the first code and then you're going like, okay, I'm going to tweak it. Then I run it again and things crash. So it seems like it's a random error, but it's not. You run it, it cleans up, things are good. You try to run it a second time, it tries to look at that and it says, no, I don't have that. It tries to allocate a new instance of this and it says, no, that's a segmentation fault, and R crashes. Why it worked in the original C++ code was that because it's a standalone executable, it runs, it exits it, everything's fine. Deletion happens before the program terminates. There's no worries about memory leaks or anything. But a standalone program is not written for library code, and code needs to be written for a library for it to be included in R. And because this code wasn't written as a library in the first place, a lot of these issues came up. It was never tested to be run multiple times. So the fix, instead of it just deleting in the cleanup, you clear out the cache of things, not you don't delete it. Because our sessions are permanent, static members do live beyond individual function calls. The pitfall 3, testing. If you're not a fan of unit testing, you should be. Test that has already been mentioned. I love test that. Use it. And one of the issues that we found was that we're doing log likelihood computations. And so log likelihoods were coming back as negative infinity in the R package, which indicates that it was basically an impossible state. It started in an impossible state, or it somehow got into an impossible state, which it shouldn't have been. The original C++ worked fine, at least it seemed to. One of the bugs that I came across was this. It had a state type enumeration that misnumbered the states. It misidentified them, and so sometimes the state was hard coded as 0, 1, or 2, and at times the enumeration was used. Enumerations have their place, and they should be used whenever. It made enumerations make code a lot easier to read. The colonized and the latent parameters were swapped from the definition to what they were being used as in the code, which broke the model. This took 2 weeks to find, and that's a lot of programmer time that is expensive. So why didn't the original code catch this? There wasn't any comprehensive testing, and the testing that was done was its own standalone program. There wasn't any verification that the likelihoods were correct. And it was a complex Bayesian model with lots of moving parts. And as long as it came out looking reasonable, it's assumed to be working correctly. And there's a little bit of confirmation bias. If it compiles and it runs, it looks like it's right, it must be right. How I found this was comprehensive testing suite and comparing my R code or the wrapped C++ code going through R versus the original C++ code output, which necessitated injecting a lot of debugging code into the original programs so that we could output like this portion of the likelihood is being computed and being added on, and so on. So that we could do a line-by-line likelihood contribution analysis and say, oh, it's actually this one parameter in this one subject that is creating the impossible state. And then a systematic debugging of every parameter, which there were a lot in this code. So the code worked in C++, but some other things were not a number came out. There were edge cases that weren't handled, like logit of 1, infinity. There was a lot of confusion in the code about whether we were doing a 2-state, which would be colonized infected, versus a 3-state, which would be colonized latent and infected. And the code put those kind of in a weird order. So 1 and 2 were colonized, uncolonized, and colonized. And then the third level was latent, which in my mind is kind of like latent should be in the middle, but it caused some confusion in the and some specialized code that had to go from 2-state to 3-state model. There was some other not a number errors. Common theme is that when code runs without crashes, it doesn't necessarily mean that the results are correct. So my key takeaways that you can implement in your practice. Comprehensive testing, it caught 4 critical bugs. Do a comparison if you are wrapping legacy code, make sure that that legacy code is correct and that your wrapping for the code is giving you the results that you expect. Run checks early and often. Document as you go. I spent basically a year trying to manually debug this and then an additional 2 months with AI assisted debugging, and the AI was able to catch some of these. Like I was not able to catch the static deletion bug on my own. I had AI caught that for me. AI is your friend here. But as we go, it documented like these are the fixes that I've implemented. I made it create a Copilot documents directory where everything that it did, it documented there. So anytime I needed to go back and say we broke something, it could know exactly the history of what we've done. I went in incremental fixes, no total refactoring. If I had to do it again, I would probably rewrite the whole thing. But that was not in the scope statement, so I didn't refactor all the code. But I was sorely tempted. Things that didn't work, don't assume that legacy code, because it's legacy, it works. Don't trust your parameter defaults. Don't skip edge cases, especially if you're trying to make code ready for production. And that's kind of the bottom line of it is this code was not production ready code. And it was code that needed to be cleaned up to be made ready for production. It was great for the one-off papers that were being done with it, and it worked for that, but it didn't handle the edge cases and the things that would come up if you have a program that's being used over and over and over again. So also don't make obvious fixes without verification or testing. Some things that I would do differently if I had to do this project over is I would identify all the C++ memory allocation issues early and take preventative steps for those. So identify all the allocations, all the deletions. That would have revealed the static deletion issue. And there was some custom allocations. I would have very early on switched to shared pointers or standard vectors or standard map containers, which this also was not using the standard template library, which would have needed some refactoring. But validate all your parameters, paths end to end, and compare with the original continuously, and test the multi-run strategies. Test.
Nice.
Silver lining, converted to R. It works. It's on CRAN now. It's got a complete testing suite. It made research reproducible. So thank you.
Awesome. Thank you, Andrew. That is really great. If somebody has a question,
one more caveat.
Oh yeah, okay.
To create this presentation, I said, AI, look over everything I did and make me a presentation. So AI helped me with this presentation to say like, okay, these were the bugs, these were the issues that we found. And yeah. So I did use AI.
Oh, that's cool. That's cool to hear. Yeah, nice. Awesome. I know we're just past the hour, so we'll wrap up. But if you've got a question that you want to ask, you can type it in here in chat, and I bet a few folks can stay after to answer things. But I just wanted to give a huge thank you to everyone who prepared a lightning talk. It was really great to see this like variety of topics and the different kinds of things that people were working on. So thank you all so much for being willing to come and share for a bit of what you did. If you keep an eye on our meetup page, and you can hear about what we're doing next month and into the months after that. And thank you all so much for coming, and I hope you have a great beginning of the year.